First of all, let's start this presentation. I'd like to thank everybody who's here. Thank you for coming and joining us on this talk. We'll be looking at Box Enterprise Security. This is an introductory presentation on enterprise security and how Box does it. First of all, like I said, thanks for coming in. I know this looks like a very intimate presentation. It's going to be very nice and small. We can have good conversations and discussions, so feel free to ask questions if you have any, or we'll hold the questions at the end. We'll have more discussions then. But yeah, we'll try to keep this engaging, especially this is the first session after lunch, so I hope everybody's awake. But we'll keep it engaging a little bit. So let's start. A little bit of introduction from ourselves. We are here to talk about enterprise security. My name is Sudeep Bhowmick. I am a senior software engineer at Box. I've been working on Android for about 8 years now. I don't know if you guys remember one of the first Android handsets, the G1, the one that was a brick-sized phone with keyboard sliding out and stuff like that. I was working on that back then. But yeah, I've been enjoying working on Android, and I have Don with me.
Yes, my name is Don Cung. I had the luck of working on Android in 2005 before the acquisition by Google. And I've been working on the Box Android team for over 8 years now.
Cool. All right, so let's start with a bit of an introduction on what Box is. So just a quick show of hands. How many of you here know what Box is or who have heard about Box? Awesome. This is much more than I actually expected to. Cool. We'll give a quick refresher what Box is. We are a secure cloud content management provider and a service provider for enterprises. What we do is allow enterprises in industries like healthcare, education, government, those kind of industries to securely manage their content, their collaborations, and workflow on our platform, using our platform. So I talked a lot about industries. The clients that are in our industries are about healthcare and government and education and public services and so on. So as you can imagine, these customers rely heavily on Box for security and compliance. So we take pride in our platform being compliant and certified for all of those security needs that these enterprises have. So we allow the enterprises to do collaboration, internal and external collaboration. What I mean by external collaboration with their content is, for example, you work in a company, you created a document, you want to share that and have it reviewed by somebody outside of your company. You can do that using our platform very securely and in a very seamless and frictionless manner, for example, by sending a link to the external person, which is access controlled and easily accessible. We allow workflow management using our platform. What it means is basically you can create, for example, if you're you're a company that requires contracts, you create contracts, but you want to get it reviewed by an external legal team, for example, or an internal legal team for that matter. So what you do is you create a workflow around that process. You create a document and then you assign tasks to the legal team or a lawyer, and then that person reviews it, sends you feedback, he approves it, denies it, rejects it, so on and so forth. So that's kind of an internal workflow that we manage securely for our customers. Having said that, let's talk about why we are here today. We are here to talk about enterprise security, specifically enterprise security around clients that we have. We have cross-platform clients, but we'll try to focus on Android here in our talk today. We'll be talking a little bit about some Android tools that we use in our app today, and beyond Android, outside of the client, some user behavior security and things like that, which will hopefully give you a good picture around how the security starts on the client and how it ends on the client, or outside of the client, and accesses and secure user behavior, for example. So we'll go through these 4 main bullet points. Securing the device, which basically means is that we will go through in brief introduction about how you make sure this device is secure on the device that the end user is using to access your content, the enterprise content is secure. We will also talk about, once you know the device is secure, how you make sure that the user is authenticated and securely be able to log in. We talk about securing the content once the user has logged in, how do you make sure the content is being securely accessed and used. We'll talk about securing user behavior, as in how do you make sure that the user behavior is also secured beyond just accessing the content. So I'll pass it on to Don. The way we'll do it in this talk is Don will take us through a couple points, and then I'll jump in and do the rest of the points. Don?
All right. Thank you, Sudeep. Okay, so the first part of creating our enterprise story is we need to make sure that the device that the enterprise's users are on is secure. And so what this means is each enterprise will have a certain standard that they need all of their users to be on. And we brand this device trust. And so these are basically a series of checks and that the enterprise can set against their clients that we will perform before giving them any sort of access to the enterprise's content. And so the first of these is going to be, is the device rooted? Because if it is, then we can't trust anything that comes from that device. And most enterprises won't like that. The second is OS version. There might be some security holes in prior versions of Android or iOS that these enterprises don't like, and so that will be a simple check that we can perform that makes them happy. And in addition to that, they might require certain software to be installed, such as a firewall or an antivirus, or have a passcode. Those are all things that we can be checking. And something we do on our server side is we do IP whitelisting. So some of the enterprises can require all of their users connect only from certain trusted IP addresses, such as their own corporate networks. All right, so in order to enable root detection, luckily there is a solution that Google provides called Safety Net. Otherwise, this is a very difficult problem, and there are MDM companies that basically have their entire business about this. But essentially, what Google's Safety Net API does is it's an online check where they will send a profile of the user's device to their server and compare that against a database of all known manufacturers and ROMs, and then they will provide back whether the device is rooted or if it matches a CTS profile. And all of this is supposed to be validated against your own server-side implementation, because if the device actually is rooted, you can't check any calls against it because those could be compromised. In addition to that, Google encourages you to protect the calls in case someone takes your API key. They might use up all of your quota. You're limited to about 10,000 by default, but you can request for Google to provide a few more requests per day. And implementing it's relatively easy. They have a builder. You basically will provide a nonce that you would generate on your server side, the API key that you would get after you register with Google, and then you would add a success and a failure listener to your own app. Of course, you'll have to call your own server side in your success condition to validate the JWT response that they'll give back. Okay, next. Sometimes that's not enough for some of our enterprises, and they pay for one of these more expensive solutions. And these are called mobile device management solutions. They're something like an AirWatch, a Mobile Iron, a Mass 360. What they provide on top of just root detection is they provide device monitoring, They can see what all of the users of the enterprise are doing on that device at any time. They can check the IP addresses and all the apps installed on the device, because the user, prior to installing that, will have to give them device management permissions. As part of those device management permissions, they can also wipe out certain things on the device. And they can also force the user to do things like have a passcode or have certain apps installed that might do the firewall and device protection. Right, and so there's also a great value for our app just to make sure that your device is managed by one of these MDM services. We term this solution Enterprise Mobility Management, or EMM for short. But this is basically our set of tools that give an enterprise a solution for making sure that they are fully managed and configured properly. So we do this through a server-side check. The first step of this is an enterprise who wants to set up EMM will register with our CS agents with their MDM information. So we've partnered with a few MDM providers, and they will be able to configure a backend handshake with us. And so the first step is that information is provided for each enterprise. The enterprise will then roll this out to their users with some information that we've provided to their admins. And then when one of those users actually logs in, they will get that information through their MDM application. This also might be through Android Enterprise, formerly known as Android for Work, which is a series of configurations that we can set in our application that we will get back by an admin. And once those configurations get to our application, we will basically send them to our server side. And because we've already set it up for this user and enterprise, we can do that handshake against the MDM server to make sure this user is enrolled in MDM on their device. All right, so the next thing that we need to do after we make sure that your device is safe and properly monitored is we need to authenticate the user. And so that's generally fairly simple through a username and password in the simplest case. Many of our enterprise customers will go through their own SSO, which is a single sign-on that they'll use throughout all platforms. And in addition to SSO, many of them will require an additional two-factor. This could be through Duo or an RFID key. Most of this is going to be done through the SSO webpage itself, although we do offer a two-factor solution for enterprises who have not set up an SSO. And that will just be through SMS or another means. And yes, some of the enterprises will also set up certificates on these devices that will further authenticate the user. And finally, enterprises can have the option of pinning the device. And this is a very simple thing that can be done, which is just a unique ID that we generate on first install of the application, and that we will always send with any sort of refresh or login attempt. And if that doesn't match, our server will realize that this is a different device than the original. And enterprises can set a certain number of pins to allow. All right, I'm going to hand this off to Sudeep now.
All right. Okay, so let me just go little bit further here so that I'm closer to the audience here, but not directly below the screen. Okay, so we kind of saw a little bit about how we secure the device, so make sure the device the client is accessing content on is secure, how we make sure that the user is authenticated so that the access to the content is secure from the get-go. Once those two things are done, now we still have a problem, or not a problem, but an ask from the enterprises to make sure that the content use is still secure. How do we do that? There are a couple things that Box does, and these are meant to be, guidelines and things like, this is what you can do for starting off with enterprise security, which the enterprises actually like to do. Things like some enterprises ask for passcode lock on the app, and they require the users access, set a passcode. Enterprises will control if the users are allowed to download a file on their devices or not, or if they say yes, you cannot download a device or download a file, you can only download on encrypted devices, or control content copy pasting and control content printing, for example. These are all things that the enterprises want the users to enforce, or the devices to enforce, or the apps to enforce. Because ultimately, the content is owned by the enterprises, and the enterprises do not want their content to be leaked or data leaked in any form. So these are some of the things that we can do. In this talk, let's go through a couple things that might put a perspective on how we do this on Android. Let's start with app passcode lock. If your app wants to implement that app passcode lock, there's a certain generally available rules that is a good idea to follow. You make sure your passcode passes minimum length check. Store the passcode as a secure hash on the shared preferences, for example, and make sure that any modifications to already set passcode is secure. But beyond that, what can you do to make sure it's a step beyond just a passcode lock? So what does a passcode lock do? It's basically allowing the user to say, hey, I want to make sure that only I can access the content. If a device gets stolen, if the device gets unauthorized access, and the user can, or the third-party unauthorized user can actually start up the app, he or she will not be able to access the content as long as it's not authorized. But in Android, for example, the recent stack actually saves a snapshot of what you were doing last time. So even if you have a passcode, there is another way for data to get leaked. So you could also look at certain other things to disallow that. For example, in our app, we use the flag_secure flag to make sure that we disable screenshots and disable app snapshots in the recent stack also. This is kind of a step beyond of what we are, what we provide us as a passcode log, for example. Then let's move on and quickly see what we can do about device encryption check. You guys already know that the Android devices nowadays are encrypted by default by using a manufacturer key. But that's not entirely secure because the manufacturer key possibly could be shared across devices. And the point of encryption is to make sure that only the user who owns the device can see the content of the device. To start with, you can use Device Policy Manager. That's what we do on the Box app to get or query the storage encryption status. But make sure that when you do query the storage and encryption status, pay attention to the return code and make sure that it's not manufacturer default. If it's manufacturer default, that's not secure. You might want to ask the user to secure it using a PIN code, and there's something called secure boot option that you have to go and enable on the device to make sure that the storage encryption status comes back as enabled, and that's then considered secure. So that's something to keep in mind. So what we've talked about here, and the snapshot I showed you a couple slides ago, was that you can control this behavior, or the enterprises can control this behavior using something that Box provides as a configuration on using their web app UI. So it's called Client Admin Configuration Setting page. You can go there. The enterprises can actually do that. But let's say we're writing an app. We don't have access to that kind of server backend. What we can do is still make our app secure by using something called, or using the remote config from Google Firebase, for example. You can still use Google Firebase. You can still configure a remote configuration through Firebase to be sent to your app. and control all of these settings or any settings that you would like to using that configuration itself. So you don't really necessarily have to have the backend infrastructure to do this, to make sure your client is secure. All you need is a way for you to transport that configuration or the direction from an external source to a client. That's one way to do it. Okay, so we talked about a little bit about how we could try to say, is the user accessing the content securely, and how can we enforce that? Beyond that, there are other things that the enterprises also like to see is, for example, enterprises have various levels of access control. You have content that's public, you have content that's private, you have content that's confidential, and so on and so forth. They would like to control access that way. They would like to control. They would also like to see what's the user doing with the content that they've been given access to. So Box provides a service called Box Shield. What this is basically does all of this, what I just said, does all of that for the customers, for the enterprises. On the left-hand side, you see Smart Access, which basically says we can allow the enterprises to say this particular user has access only restricted and above, or restricted and below, but not confidential, or something similar to that along those lines. You can set your custom labels for content, for example. And on the right-hand side, you see threat detection. This is kind of going on towards securing user behavior rather than content. Imagine that you have users, you allow users to access content on your device, but the user sometimes might have malicious intent or ambiguous behavior which the enterprises don't like. So what we do is we allow enterprises to detect that also. This is a snapshot of what the Box Shield dashboard that the admins see on their end. If something does happen, they get alerted. There's tons of alerts, and you can go through those alerts and see what's going on. For example, in this case, if you notice, the deviation is that that particular user downloaded content on that device, which is 1,200 percentage times more than what that user usually does. So that user actually downloaded 24 GB worth of data, which he or she doesn't usually do. So then that kind of creates a flag. So this is a dimension towards securing user behavior rather than content. You know how to secure content. This kind of gives you that extra step. So how do we do that? This is kind of a very quick slide of how Box does it using Box Shield. On the left-hand side, you see the user activities that get piped in to our backend. There's a service called Box Graph. What it does is it's basically machine learning-based service that runs various different machine learning models on the data that's coming in. And the way it's trained is to send out alerts in case it detects certain anomalous behavior and so on and so forth. So that's what you see that's getting piped out of Box Graph. On the top, you see Shield dashboard. On the bottom, you see security partners that also get alerts in case you've subscribed for those alerts for the enterprises. So that's the reason I point this out is because this is kind of going beyond just securing content. It's securing behavior and user experience beyond just content. Now, you've done all of this, but there's another kind of dimension to secure content management. Is making sure what happens when the content is no longer needed. We call that EOL, is basically end of life for the content. When the content actually reaches that end of life, what do you do? Do you want to keep it alive in the system, keep it sitting in the system for a while? So Box provides something called Box Governance. This is another service. But basically, the reason I highlight this is enterprises have asked us to do this, where they say, for various reasons, for legal reasons, for compliance reasons, that once the content reaches its end of life, the enterprises can set how many days that end of life is, 30, 60, 90, 10 years, and so on and so forth. But once that expiry is reached, what happens to the content? It gets deleted. It gets a label gets changed or whatever, it gets more restricted, or so whatever the enterprises want to do with the content, they can do. So that kind of goes all the way, rounds up the content from all the way from creating the content on the mobile phones, accessing the content, and then what happens once the end of life happens for the content. So this kind of gives you a full overview of how the content gets managed on an app, and hopefully This gives you all of these four bullet points that we just started with: securing the device, how we actually secure the device using device trust, for example. You use MDM, mobile device management, to secure the device. Once you have MDM and device trust and all of that in place, you can use various ways of authenticating the user. We saw how to authenticate the user experience or secure the user experience by using Shield and governance. You can also secure the content by making sure the app does certain, follow certain restrictions that the enterprise has set. So all of these things are kind of just an introduction of what it means to be an enterprise-grade app. And if you are looking to put in some of those controls in your app, you might want to look into some of these things, and hopefully this helps. But there are a lot of tools out there. Google provides Firebase, which is a great tool to start with. Device trust, safety net. Device trust is a box term, but safety net is a tool from Google that is, you can use it to very easily detect if the phone that you're running on is rooted and whatnot. So all of these tools kind of help us give a more secure experience and help secure the content. I think this is enough for our presentation, but we are now open for questions. If you have any questions at all for us, we're happy to answer. All right, thanks.